Hello again and welcome to the secret labs of BauTek Industries. Tonight we're going to take a look at this, the Mech Control 2000. What this lets us do is take the input from a recumbent exercise bike and control video games with it, which is a pretty cool way to get your game and your swole on at the same time. I built the original version sometime last year, and unfortunately it fell apart thanks to the MDF just disintegrating, which it kind of does after time. So while I was fixing things, I decided I would revise it. I'd move the keyboard, update this controller code, add a second joystick, and a few more things. I'll kind of walk you through the process, the damage we dealt with, how the controller works, the software, and then at the end, we'll play us some Descent here so you can see it in action. So here is the main structural problem. Those hinges have gotten all loosey-goosey because the screw channels have started to strip out, and you can see the MDF is cracking here. It's not really made to take loads like this, and I knew this was going to be a temporary solution at best. I really wanted to put a welded crossbar in here, but I still don't have any welding equipment, so we're just going to get some nice thick aluminum angle, bend it to the proper width here, or the proper angle, and then sandwich it top and bottom to just hold these in place so they don't do that again. Here's the keyboard side of the thing. Just got a regular old USB keyboard here, and then up top is our controller that runs the whole mess. And you can see here that it's chipped in the corner, and this already happened over here as well. I should have fixed this at the same time, but this is just some really cheap eBay hobby board, and I'd pretty much stay away from this stuff if you can because it's just crap. But it works for now, and hopefully once we put some more bracing in top and bottom, this kind of thing won't be an issue. I could also stop beating on it, which would help quite a bit too. But let me show you what the inside of this keyboard looks like so you get an idea of how that interfaces with this and then controls our game. Let's pull the top off here. And then what you've got underneath is just kind of the same thing that's been running most keyboards for the last 15 or 20 years. You've got this rubber membrane here that provides a little bit of feedback. If we peel that off, underneath you've got another set of membranes here. You've got this top plastic layer and then the lower. It's kind of hard to see on this lower because of this cross-hatching, but let's look at the top here. And you can see it's got a number of traces running across it with these little conductive dots. And if you follow those traces, they run up to one of two lines here on the keyboard controller. And what happens is, say you want to hit the W key here, you push down on that and it'll short out the 2 points on the top and bottom, which will short out a point here and a point here respectively. And then on the back side of this guy, you have this cute little IC here, which is just an 8-bit keyboard controller. So it takes those two lines that are shorted, looks it up on its own internal table, figures out what key you're pushing, and then sends that back to the computer through the USB interface. You can see here we've got the controller wired directly up to that membrane here, and then we're just pulling our 5-volt power right off of the USB bus to power all of that circuitry up there. And so basically what it does is it shorts everything out through the shift registers and through these quad switch chips here. That comes down through our fancy rainbow ribbon cable here, and then it shorts out the two membrane points without actually any physical contact here. It's good enough to fool the controller, and it sends the key back down to our computer. Here's the insides of the whole mess. Very simple. The pedals here just drive the belt in the middle, and then sitting on top of that is our addition, which is just this crappy little circuit board that's spring mounted so it keeps constant pressure on the belt, and then this wire runs up to our microcontroller to give us the readings. I'll show you here how I created the center pedestal for the keyboard. So we moved that from the user's left to the middle, and the important thing with that was that it was both tall enough to clear your knees as you're using the bike, and it was close enough to the user so that you wouldn't have to stretch way out when you want to hit keys or adjust the controller. So I'll speed that up and you can kind of see just how I mocked it out real quick with the cardboard, cut it into the MDF, painted it, and then we mounted it to the bike. there we are with the center pillar cut, painted, and mounted. Now we'll move on to getting these dang struts fixed, and that should be it for all the structural stuff. Well, everything was going good for about 5 minutes. I replaced these wimpy little hinges here with some proper angle brackets. They're much thicker. And everything went well until some quick play testing when, well, I snapped the strut right in half, which is no surprise, because if you look at this stuff, it's just like pressed cardboard, fine for display purposes, things like that, but structurally, yeah, not too sound. So I said, screw it, went to Menards, got some 1x1 aluminum tube, and this is what we have now. With the bracket on the top, this is pretty much going to be indestructible. Hopefully, we'll see how it goes. We have one more piece we're going to add to our control circuit here before I bolt everything back up and we use it again. And that's this. One of these awesome missile launching safety toggle switches. Figure you can't go wrong with at least one of these in a project, and I've got quite a few of them laying around, so I'm always looking for an excuse to use one. What we're going to do with this is we're going to use it to toggle the power on this little USB hub here. This sits on the keyboard, or behind it I should say, and provides power to a USB headset, the keyboard that this is connected to, and a mouse. And since the computer that this runs on is my media center PC on the TV upstairs as well, I don't really want to leave this controller running all the time. Not that I don't trust, you know, this mess of wiring not to catch on fire, but we'd rather leave it off when not in use. Alright, here we go. Power switch is mounted and working like a charm. I just severed the 5-volt lines on the PCB of the USB hub, ran them up to here to control power, and then you'll notice we have a second switch off to the right there, which is controlling this guy. A little fan that helps you keep cool while you get your game on. That was pretty much the last thing we had to do to finish the upgrade from MechWarrior 1000, or Mech Simulator 1000 to 2000. I'll give you a quick look at the overall design here, and then we'll dig into the software that runs the controller and the joysticks. So here we have the keyboard mounted to the central pillar that we cut. And then you'll see we've got a second joystick platform now, and the aluminum struts, which are holding up extremely well. Each joystick is mounted using 3M command lock. That's this stuff here, which is like a mushroom-headed fastener, kind of like Velcro on crack. You do have to be careful with this stuff. I used a whole plate on one joystick and had to use a pry bar to pop it off, so less can be more. Each side is running a USB extension rather than the device cables, so you can swap out joysticks if you have a preference or need a different controller for a game. For instance, on this right side here, we have this, which is really just a glorified mouse pad with more of that command lock on the bottom. So if you don't like playing your first-person shooters with a joystick, this is for you. What I'll do now is we'll take a look at the software, and then I'll tell you what, we'll hop on and we'll give a game or two a shot and show you how it works in action. Here we'll take a look at the software that makes everything tick. There are really only two important pieces to this project. There's the Arduino code that runs on the controller, that handles all hardware aspects of it, and then there's Pinnacle Game Profiler, which is what we use to remap the buttons on the joystick to either emulate keyboard presses, X input for games like Hawken that don't accept normal joystick input, or other axes or other joystick buttons. It's pretty slick stuff, so we'll go over that. Let's take a look at the Arduino code real quick and how that interfaces with the hardware though, and then we'll move on to the game profiler and I'll show you how those buttons are set up. The Arduino code isn't too terrible once you break it down. Ignoring the LCD, we're really only using 6 pins on that puppy. We've got 3 for the serial data out to the shift register, our profile buttons, and then this rotate sense pin. Now this is the most important part since this takes the data from the bike, and then we use that value to figure out if we're going forward, backward, or what speed that happens to be at. This works really simply actually. If we pull up the diagram, we've got our motor right here, and then that's running to this bridge, which runs to the analog input here. Now these analog inputs in an Arduino can only read between 0 and 1020 or 1024. No negative values. So what we have to do is we have to take the 5 volts that actually references off of the Arduino into this bridge, and this cuts it right down the middle. So what we're really seeing at rest here is about 512 for a value. When we spin the motor, it acts as a generator, so it's going to either raise or lower the bias on this bridge, which is going to raise or lower the value on the pin. So it'll go from 512 to maybe 640 if you're pedaling fast, maybe 720 if you're going all out. And the same goes for reverse. It's going to go from 512 down to 480, maybe down to like 460. So this works pretty slick and is actually pretty dang reliable, so not too bad. Moving on to the other parts of the code. This is just some special characters here. But these are the two bytes right here, active byte A, active byte B. These are sent out to the shift register when a change in speed has been detected. If we look down here, these are the actual patterns themselves. Now, for some reason, with the Arduino IDE, we have to store these as decimal. I can't remember exactly why that was, but there is a bug there somewhere, so something you have to watch out for. But you can see exactly how that works here. So let's say if we set it to a value of 16, that's going to shift this out to the first shift register, and this 1 here is basically going to coincide with the pin that we want to short out on that keyboard controller. So we set one of these for each side of it. It gets shifted out, shorts those pins, and we get a keyboard press. We do have some special patterns here, and these are just if you're holding down like up in control, up in J, things for like jump jets, running, stuff like that for the first person patterns. And then we can skip all this. This is just shift code for moving stuff out, and then more trigger shifting. And here we go. These are the actual values that we set from that motor. I just have a little reference here for what I measured, and this depends on what motor that you use. You'll see stop here is 508 instead of 512 just because of like resistance from the wires and stuff like that. And then these reverse values are what I chose just based on testing. And then we set our throttle, gets shifted out, and off you go. And then here's kind of the different profiles. You can create or remove profiles at will, and this basically just determines, depending on what speed is detected, you know, what byte we're going to shift out to the shift register to make the key that we want. And then we have some things like if we go to the shooter profile, it requires constant output, or constant input I should say. So instead of just tapping a button to set a throttle, it needs to hold it down. Whereas Mech Warrior is a little different. There you actually push a button to set throttle and you don't have to hold it down again to keep going. So there's small differences like that, and each profile accounts for those differences. So that's it for the Arduino code. That'll be uploaded to the blog so you can pick it apart, use it if you want to. Let's take a look at Pinnacle Game Profiler, and that's again how we set both joysticks, how we set the buttons, the axes, and stuff like that. So here's Pinnacle Game Profiler. This is the software that lets us map the buttons on both joysticks to use in the games. I've only got one joystick and one profile loaded, but you'll kind of get the gist of it. So here we pick our device, and then you either pick left or right stick. If we look at the configuration, these are pretty dang straightforward. What you do first is you set up your standard commands. So what we do is we say secondary fire, that's going to be holding down Alt. Rear view, hit V. Primary fire, hold down Control. Pretty straightforward, right? Then you map them to the button you want, and presto! That's what that button will do when you press it next. Pretty slick, right? Things like the actual X and Y axes of the joystick, here we can map it just to WASD. It's got a built-in mapping for that. And then the first axis here, which is the bank left and right for descent, this is pretty cool. Let's go to compound commands here. And here's the twist axes. So let me get that initiated here. So there it is in the middle. When we twist all the way left, that's zone 1. That's set to bank left, you can see. And then twist to the right is zone 3, which is set to the bank right. So it's like holding down the Q key and holding down the E key if you remember playing Descent back in the day. We've also got a profile in here for cycling secondary or primary weapon, depending on which stick you have selected. And that's pretty cool. So like, I don't know if you remember Descent, when you select weapons, there's really not a cycle button. You press 5, or you press like 6, 7, 8, or 9 on the keyboard. And that's what this select secondary buttons are set to. So every time I hit D-pad, it'll cycle through this list and hit each button. And then, you know, hitting left goes backwards through the list. It reverses when you get around to the edge. So that's a pretty cool way to cycle weapons without having to reach up to the keyboard. That's it for the overview of all the changes and upgrades we've made to the Mech Sim 2000 rig here. Thanks for watching. I hope you enjoyed. Take a look at the website down below, kungfutreachery.net, which is where we keep all the BauTek industry stuff. I'll have the code, schematics, and other details on this project listed there. And also subscribe if you will. I'll be doing some updates down the road with some NES Advantage upgrades, a 3D printer, and a few cool things like that. Thanks again for watching. Have a good one. Time for some action. I'll hop on this beast, we'll fire up Descent, and then we'll play through the first level and blow some robots up so you can see how this bad boy works in game.